In the last video, we have seen the relation functions, certain concepts and equivalence relations, and today we will do certain problems of Ncert exercise 1.1. Before that, let us see JEE sums set in 2018. A set is given and two relations have been defined. A set is given and two relations have been defined, and options are R1 is not symmetric but it is transitive. Both R1 and R2 transitive. R2 is symmetric but it is not transitive. Both R1 and R2 symmetric. Now, in the given relations, two relations defined on the set A, if you will see that the ordered pair, the AA, BB, CC, the reflexive. Now, AC, CA, symmetric, but BC, CB is missing. So, it is not symmetric. And it is transitive. If BC and AC, if you make the ordered pair, BC and CA, what you are getting? BC and CA, you are getting BA. BA should be there, but BA is missing in R1. So, R1 is not transitive. So, this option is not considered. Now, coming to both R1 and R2 transitive, already we have seen it is not transitive. So, option B is deleted. And coming to C is R2 is symmetric. Let us check A, B, B, C, C, the reflexive. AB to BA, CA to C. This part is clear, but it is not transitive. If you look to these four pair, now AB and CA, if you make it CA and AB, what you are getting? The second member is equal to first member, so CB must be there, but CB is missing here. CB is missing here, so this is correct. And both R1 and R2 is symmetric. It is not symmetric because here BC, CB is not there. So very quickly we are able to solve the JEE problems. Only the basic concept which has its put in Ncert. Now I am going to Ncert. Now all of you must have enjoyed this one, and let us see the Ncert problems. Now coming to exercise 1.1 of Ncert. Now coming to exercise 1.1, question number 1, there are four bits. There are 4 bits. Looking to the first bit, relation, there is a set 1, 2, 3 up to 14, and R is defined as x comma y such that 3x minus y is equal to 0, and determine the relation as reflexive, symmetric, and transitive. The first bit, now for reflexive, it will see this one. Reflexive, x comma x. Here, dear student, many ask about what is the procedure, steps of writing. Now coming directly for reflexive, x comma x belongs to R. It implies that 3x minus x is equal to 0. It implies that 2x is equal to 0. It implies that 2 is not 0, so x may be 0. But this 0 does not belongs to the set A. Hence, it is not reflexive. Now, coming to the symmetric and transitive. For symmetric, let x comma y belongs to R it implies that y is equal to 3x as per the relation defined, but it does not imply x is equal to 3y. So y comma x doesn't belongs to R, hence it is not symmetric. Now coming to transitive. Transitive, let x comma y belongs to R and y comma z belongs to R, implies that y is equal to 3x and z is equal to 3y, implies that here x is equal to y by 3 and z is equal to z by 3 is equal to y. Now x is equal to y z by 3 by 3, that is equal to z upon 9, which implies that 9x is equal to z, implies that, does not imply that z is equal to 3x for x comma z belongs to R, so it is not transitive. Now dear student, in case of transitive, we have to take two elements belongs to R and they have y is equal to 3x and z is equal to 3y. So from that we get x is equal to y by 3 and y is equal to z by 3. Putting y in place of y, we get x is equal to z by 9 and converting 9x is equal to z. It does not imply z is equal to 3. Why we write z not equal to 3x? Because 9x is equal to z. So it is not transitive. Now coming to other problems, let's see. So if anyone wants the particular sum of 1.1 exercise, please write in your comment section that particular question to be solved. I will do and take the care. Now coming to, there are similar sums of question number 1. There are many bits, out of which one bit I have done it. And coming to question number 2, set. The set is given set as R, set of real number. Don't confuse, R is the relation, here R is the set of real numbers. And now here R is a relation, that's why I am writing here. R is a relation, that is the ordered pair AB, where A is less than equal to B square, where AB belongs to R, set of real number. And this is, we have to prove that. To prove R is neither reflexive nor symmetric nor transitive. I am written shortly, reflexive for R, symmetric for S, transitive for T. To prove R is neither reflexive nor symmetric nor transitive. Now for reflexive solution, this is a very important sum. It is a board sum. Maximum time students' books use the examples. Suppose the example, that is one way to solve through the examples. But another way, the most important is that Let us see this one for reflexive. X comma X belongs to R. Here R is the relation. It implies that X is less than or equal to X square. It implies that X square minus X is greater than or equal to 0 and X into X minus 1 is greater than or equal to 0 and sign scheme Now look at here, we have solved this problem beyond the examples and we see that X belongs to minus infinity 0 included and 1 included to infinity, and this is not true for all the real numbers. This is not true for all real numbers. Only we have taken two intervals, minus infinity to 0 included and 1 to infinity. This is not true for all real numbers. Hence, it is not reflexive. Now coming to symmetric. For symmetric, let X comma Y belongs to R. R means the relation implies that it does not imply for all reals imply that it is not symmetric. Coming to transitive, let X comma Y comma Z belongs to R. That means X is less than equal to Y square and Y is less than equal to Z square. So this does not give you X is less than equal to Z square, implies that R is not transitive. Dear student, we have seen this problem beyond the example, and there is a similar problem coming in the board always, that is question number 5. A is less than equal to BQ. Now we will go to the big problems where the concept is required and the solving techniques. Coming to question number 8, page 6. Set is given 1, 2, 3, 4, 5 and the relation defined is even. To prove R is equivalence relation, there is another part. There are other two parts also of this question. Now let us see this one. To prove equivalence relation, you must define, say that the relation is true for the reflexive, symmetric and transitive. For reflexive solution, for reflexive, x comma x belongs to R implies that x minus x is even. It is true. Even numbers are divisible by 2. It is true. Implies that R is reflexive. Coming to symmetric, let x comma y belongs to R. It implies that x minus y is even. It implies that y minus x is even. Dear student, absolute value of minus 1 is plus 1. So it implies that y comma x belongs to R. It implies that R is symmetric. Now coming to transitive. Let x comma y, y comma z belongs to R. Implies that x minus modulus of x minus y is even, and y minus z is even. It implies that x minus y plus or minus 2k, where k belongs to natural number, and y minus z is plus or minus 2m, where m is set of natural number, m belongs to set of natural number, implies that x minus z, that is equal to x minus y, y minus z, that is equal to plus or minus 2k plus or minus 2m, taking plus or minus 2, k plus m, that is equal to plus or minus 2 L, where L belongs to set of natural number. It implies that x comma z belongs to R. It implies that R is transitive. Now, one part of this question, a long question, 6 mark, one part of the question is over. That is, we have seen that it is a equivalence relation. We have seen that the R is reflexive, symmetric and transitive. Now, the other part of this question that it follows, that is that so that elements 1, 3, 5 is related to each other. Obviously, how we will show this part, that is 1 or are all even, implies that they are related to each other. Whenever problem comes on this concept, always please watch the relation. The mathematical relation is given. What is this? This is mod of A minus B is even. Now coming to third part. Also, all the elements of 2, 4 are related to each other. 2, 4. Elements of 2, 4 are related to each other. That is 2 minus 4 and 4 minus 2. So they are related to each other because they are even. And coming to, but no element of 1, 3, 5 is related to 2, 4. Let us see this one. 1 minus 2 is not equal to even. Similarly, we can compare other elements. Dear student, if you want any of these remaining questions to be done by me, please write on your comment section. Do that these questions. I will give the answers and the solutions, and hope you have enjoyed this video. And please, if you like this one, then share, give your comments. Thank you.